The question says that a corporation takes delivery of some new machinery that must be installed and checked before it becomes available to use. The corporation is sure that it will take no more than 7 days for the installation and check to take place. Now let event A be the event that it will be more than 4 days before the machinery becomes available, and B be the event that it will be less than 6 days before the machinery will become available. What we have to do? Firstly, we have to describe the event that is the complement of event A. So first, let us define the event A. Before defining A, let's define the sample space. What will be the sample space? The corporation is sure that it will take no more than 7 days. So that means that either it will take 1 day, 2 days, or up to 7 days, right? So 1, 2, 3, 4, 5, 6, 7. But it's not going to take anything more than 7 days. So that becomes our sample space. The event A is that it will be more than 4 days before the machinery becomes available. More than 4 days means that it will be either 5 days, 6 days, or 7 days. So this is how we can define A. And what about B? B be the event that it will be less than 6 days before the machinery becomes available. So less than 6 days means that it will be either 1 day, 2 days, 3 days, 4 days, or 5 days before the machinery becomes available. Now part A says that describe the event that is the complement of event A. So complement of event A means that complement of A is going to consist of all the outcomes that are a part of the sample space but that are not a part of event A. So all the outcomes that are a part of sample space but are not a part of event A are 1, 2, 3, 4, correct? Because 5, 6, 7 is a part of A, so that will not come in A complement. A complement will only contain those outcomes of the sample space that are not a part of A. Part B says describe the event that is the intersection of events A and B. So A intersection B is equal to, so A intersection B is going to contain all those outcomes that are a part of both A and B. All the outcomes that are a part of A and they are also a part of B. So A consists of 5, 6, 7. B consists of 1, 2, 3, 4, 5. So the only common element which is present in both A and B is only the outcome 5. So that is why A intersection B consists of 5. Now the next part says describe the event that is the union of events A and B. So union means it is going to contain all the outcomes that are either a part of A or a part of B or a part of both A and B, but the common elements will be written only once. What are the elements or outcomes which are a part of A and B both? So 1 is a part of B, 2 is a part of B, 3 is a part of B, 4 is a part of B, 5 is both in A and B, but it will be written only once. Then 6 is a part of A, 7 is a part of A. So we get A union B. Next, what we are asked, are events A and B mutually exclusive? Now, two events are said to be mutually exclusive if there are no common outcomes between the two. That means that if A intersection B is null or A intersection B does not contain any elements, then these sets will be called mutually exclusive. But in our case, we can see that A intersection B consists of one outcome, right? One outcome 5. So therefore, we can say A and B are not mutually exclusive. Why? Because they have one common outcome. The next part says, are events A and B collectively exhaustive? Now, events A and B are said to be collectively exhaustive if all the elements present in the sample space are also present in the union of A and B. That means if A union B is same as the sample space, then we can say yes, A and B are collectively exhaustive. Now, A union B consists of 1, 2, 3, 4, 5, 6, 7. The sample space also consists of 1, 2, 3, 4, 5, 6, 7. Therefore, we can say yes, A and B both are collectively exhaustive. From the question that we have been doing, we know the sample space, event A, event B, and event A complement. Now we have to show A intersection B union A complement intersection B is equal to B. This is what we are supposed to show. For this, first let's find out A intersection B. We already found this in one of the previous parts, and this consists of the common outcomes between A and B, that is 5. Then we can find out A complement intersection B. So A complement intersection B, can we find the common elements between A complement and B? That is 1, 2, 3 and 4. And now if I want to find the union of these two, that means A intersection B union A complement intersection B. Union basically means that we have to take all the elements that either are a part of A intersection B or a part of A complement intersection B or a part of both, right? So that will be from A complement intersection B, we get 1, 2, 3 and 4, and from A intersection B, we get 5. And ultimately, if you will see these particular outcomes that we get, these are nothing but equal to the event B. Therefore, we can say A intersection B union A complement intersection B is nothing but the event B itself. Similarly, we can look at the next part. We have to show A union A complement intersection B is equal to A union B. So we already know the outcomes of A, that are 5, 6, 7. We already know the outcomes of A complement intersection B here, that is 1, 2, 3, 4. So if I can find out A union A complement intersection B, I basically have to write all those outcomes which are either a part of A or a part of A complement intersection B or a part of both. So that will be from A complement intersection B, I will take 1, 2, 3, 4. And from A, I will take 5, 6, 7. Correct? 5, 6, 7. So I get the left hand side. For right hand side, I have to do A union B, which I've already done previously. A union B is going to consist of all the elements, either a part of A or a part of B or both. So that will be 1, 2, 3, 4, 5, 6 and 7. Correct? And if we compare both of them, we can clearly see that A union A complement intersection B is nothing but it is equal to A union B, and hence the answer.